Hello everyone, my name is Burak Yenier, CEO and co-founder at UberCloud. We accelerate compute-intensive applications by using the power of cloud. Let me capture your attention to one thing. We have been talking quite often today and yesterday about massive scale computing. We started with the keynotes coming from Lawrence Livermore. I think they are second or third largest data center in the US right now. We talked about cycle computing and how they run 50,000 cores on AWS. We heard from many others how they want to get to exascale and run millions of CPU cores simultaneously. Now I want to get your attention to something else. How about computing for the masses? There are engineers out there who are still doing HPC on a desktop computer. So I'm allowed to say that because Addison yesterday said 4 cores is still HPC if that's what you're running on it, right? So I agree with that. And these engineers are in pain because their workloads simply cannot scale. Although their application codes could scale, they don't have the hardware. So what could be the key differences between mass computing and computing for the masses? So first of all, you heard from the people in the room that they are running very tight coupled architectures. The hardware architecture and the software architecture is designed with one very key metric in mind, and that key metric is speed, speed, speed. And when I look at the companies that are out there which are doing high performance computing and they're running their engineering applications on desktop-like compute equipment, what's more important to them is portability and user experience. Portability meaning, can I take what's running on my desktop and run it somewhere where it will execute faster? However, keep the properties of the software as it is, so I don't have to rewrite everything from scratch. I don't have to learn command line arguments to run my application, etc. And on the user experience front, do I need to go through a month of training before I can start using the new infrastructure you have given me? Because the problem that I'm trying to solve is due tomorrow. That's what I frequently hear. And when you are also looking at the computing for masses, you don't have the luxury to customize everything. Many of these customers simply, A, don't have the budgets to pay you to customize everything, and B, if you customize everything for them, they wouldn't know how to run it. And those are the challenges they keep running into on a day-to-day basis, resulting in an HPC ecosystem where we have haves and have-nots. So a lot of people here represent corporations which are on the haves side. So I'm a bit of an outsider in that, and I represent the have-nots. So let's briefly talk about a classic example. A customer of ours, they're a chip design company. It's not a mom and pop shop. They have 70 engineers, so good size. And they run their computational fluid dynamics analyses on their HPC cluster, 10 CPU cores. And it takes 100 hours to complete one round, one iteration of their design. That's painful, right? So they're looking for an easy and faster solution. And as UberCloud, we delivered them 10x performance using the same software, using it the same way they used to use it as a desktop tool. And by giving them the power of cloud, we were able to accelerate that by 10x. And that solves their problem. When I talk about the end users who are primarily in the mechanical engineering field today, that's the market we are focusing on at this point. They tell me that their processes are iterative. They work on very interactive software applications. They want to see their CAD geometries. They want to run their simulation. They want to see the post-processing results of that, and make their fine-tune adjustments and run it again. So a lot of times the engineer does not necessarily know what the final design is going to look like, but he's experimenting. So you can't simply take that engineer, shove him on a supercomputer with 60,000 cores, hope that he's going to learn how to operate that thing and still be productive. Life just doesn't work that way. You cannot break the workflow that they're running in and hope that they will continue to be effective. Now, let me switch gears. I've been talking about the users of the software. Let's think about the ISVs. A lot of us keep saying, well, if the ISVs did this, if the ISVs did that, here's what the ISVs are facing. So they're saying, yes, we know our customers are in pain. Yes, they would like to use more compute power. Yes, cloud could be an option for them. But A, I don't have any idea how to operate the cloud. Right? I'm not a systems person. I write software. I have no idea what the returns would be like. I have no idea how much budget this will take. I have no idea which cloud to go to. That's a lot of I don't knows in front of an ISV CEO, and that's one of the reasons why they couldn't help their customers get into more, let's say, remote computing environments. And what they're looking for from the customer perspective is ease of use and on-demand access. So if you can figure out a way that an ISV can get their application into the cloud with these characteristics being handled, they're actually very interested. So here's what we have after the experiments that Sydney talked about. UberCloud has run close to 200 experiments with various end users, and we have found that taking the ISV applications and putting them into containers. I said that for the first time, so show of hands, who knows about Linux containers? Heard about them? All right. If I did this last year, the number would be probably half, and the year before it would be none because it's a relatively new technology. Linux containers are now a part of the Linux operating system. It's a core feature. Obviously, we all heard about Docker. Docker is the company which popularized containers, although they didn't necessarily create them. It's an extremely low overhead way of virtualizing and running workloads on Linux-based operating systems. And it's also characterized with very small image sizes, which means it's really good for portability. You can move these things around. So what does UberCloud do with containers? We use the containers to distribute ready to run. That's one of the keywords. So you shouldn't necessarily need an IT group as an engineer to take an UberCloud container and run it on a cloud. And the other keyword is bundles. So the container is an excellent way to bring the software applications and the tools that the engineer needs around it for high performance computing and just run that on just about any cloud. So what is inside of one of these containers? So we talked about the pain the ISVs are looking at, right? I don't know how to do this on the cloud. I don't know what problems I will face. I don't know what infrastructure I need to run with. So the application layer is actually the thin layer at the very top. So when UberCloud is working with an ISV, there are 4 layers of already pre-configured, already pre-tuned code that the ISV application runs on top of. And you're going to see a demonstration of this in just a moment. So the idea here is you should be able to take an UberCloud container and run it on multiple infrastructures. So I just picked a few that we support: CPU 24/7 out of Germany, our systems, CenturyLink, Amazon, Microsoft. And these are all various cloud operators. And UberCloud has the layers of infrastructure enablement and middlewares so that when the application code runs on top, it can run in a performant way that the engineer can use it. All right, so here's the end result of that. We are actually going to take a look at this live in just a moment. So the end result of that is an engineering code like OpenFOAM. Could be run on a public cloud like Microsoft Azure, And it can be turned on and turned off by the engineer himself. He doesn't need an IT group. He doesn't need to know how to install Linux. He doesn't need to know visualization libraries. He doesn't need to know InfiniBand. He doesn't know any of that. And it comes all pre-bundled underneath. And that green button right there is the mechanism by which he would launch it. You could do this today on your own by swiping a credit card and launching what I'm going to show you in a second. All right. So, guesses as to what this is? This is going to be our connection to the cloud. So it's not going to take a whole lot for an engineer other than an office network to have access to what we are going to look at. I'll do the demo on this. So I clicked that green button just a moment ago, and I launched an UberCloud container. It's an iChart. What you need to really see is the login button here. That's all the engineer really needs to know about. Here's a password. Sorry about that. Copy that. Okay, so the engineer didn't install anything on his local computer. He doesn't need to have anything except a modern web browser. That's kind of small. What you're seeing there, the blue screen, is actually running on Microsoft Azure, and it is going to be our engineering environment. We can even make that larger. Usually when I do this in front of an engineer, he goes, I didn't know you could do that with the cloud. I didn't know you could resize it. Here we go. So everything that's running here is actually running now on Microsoft Azure. There's nothing local on my computer. You're seeing it as a remote desktop. And I talked quite at length about it has to be interactive. So I made it a little too big, I'm sorry. Okay, I want to see the whole screen. There we go. An engineer's desktop. Here's a CAD geometry. And I'm doing that over quite unreliable cell phone connection. So an engineer should be able to have access to this level of technology if you do it right. And underneath now, what's running is there's a server that got spun up on Microsoft Azure. It is a dedicated server. There's no one else running on it. It has 32 CPU cores, because that's what I selected. It can go from 2 to 32, anywhere in that range on one machine. And UberCloud supports clusters, so it can be more than one clustered with InfiniBand, or let's say Microsoft version of InfiniBand, whatever they're running there. It's not public info. And the desktop view is in front of the engineer, so he can use it like he would use it on a desktop computer. So the motto is, runs like a desktop, only much faster. And the spin-up time is within minutes. So again, we're not talking about massive compute. You are not going to achieve 50,000 CPU cores this way, but you are not going to also have 6 months of procurement time. You're not going to be talking about $1 million of budget. This thing will cost you under $10 an hour. So there's use cases of HPC at the supercomputer scale. However, many engineers are nowhere close to that kind of scale, and there are many of them. And we believe this type of a solution, done right, can bring the masses into high-performance computing. And once they understand how to use this and get the benefits into their company, one day they may graduate to much larger in-house clusters. Who knows? So obviously, showing you CAD geometry on the screen is not necessarily high-performance computing. But believe me when I say this machine does have the chops. So specifically here, you're looking at 32 CPU cores, 450 gigs of RAM. So it has OpenFOAM pre-installed. So there's nothing for the engineer to install at this point. There we go. I didn't give it any input files, so it will obviously error out, but as an engineer, I could start computing on this equipment right away without having to do any work. And when I'm done, I just spin it down and I stop paying. So there's no maintenance work that requires an IT group either. So, by the way, I have a much larger cluster running again on Microsoft Azure. I can share it with you during the break time. I won't get into it at this point. And if you're ready to try it out, UberCloud is ready to give you a free experiment, and we are able to fund that with the sponsorships that we get from companies like Intel and Microsoft, thanks to their generosity, and other UberCloud participants. And on an annual basis, we put out the case studies, so the entire HPC community can learn from what we have experienced while working with the masses who are trying to get their hands on high-performance computing. And I would be happy to share those case studies with you as well. Are there any questions that I can answer? Yes?
If I have that running on my desktop and I want to get to there, what would my experience, what do I need to go through to get from here?
Okay, that's a great question. The question was, what if I had that set up on my desktop computer? How would I get from my desktop to there? So UberCloud containers can run on any Linux distribution at this point, so you could really have it on your desktop computer. And going from your desktop to an environment like this, the end user experience is exactly the same, so you would feel at home. All you would move actually would be your data. So you would just take your input files and get them into the container that's running on Azure, and you would continue to compute.
What I mean is, do I need to have a process to package all my software and tools and containerize them?
Yeah, that's a good question.
So you would provide the tools to
That's a good question. So currently we do the containerization for the ISVs. So we would work with your software vendor and create the container solution for their product, and it would be tested by the software vendor, so you know that it'll be working code. There was another question somewhere here. Christian.
Can I create my own settings for the desktop on the cloud? So if I have my own Emacs or BIM or what have you settings, can I pre-stage this in this HPC user that you haven't tested for? So you will have the same default user all the time, right?
This is a good question. So where is the user settings? Where do the user settings live? That's an excellent question. The containers are set up currently such that they are treated as transitionary, meaning we expect that you come in, you do your compute, and then you offload. So what we do with engineers, for example, if they want a specific tool, we say, please let us know so that it will appear in the image. So every time you launch the image, it will actually have the tool set that you're looking for. For example, the CAD program that you saw on the screen there was not part of our original design. One of the engineers recommended, hey, I want to see my CAD. And now everyone can see their CAD files. So good question, Christian. Thank you. Yes?
Does your technology support GPU computing?
The question is, does this technology support GPU computing? The answer is yes. GPU computing is used in high-performance computing in generally two ways. One is for remote visualization, and the idea there is what you saw on the screen was nice, but it could be even nicer had it been, let's say, HD quality graphics, and we have the ability to run HD on the GPU on the server and ship HD graphics for visualization to your screen, and you don't need a GPU on your local machine. So the answer is yes. We do support GPUs. We run into it in this visualization sense more often. The second way GPUs come into play, obviously, is for compute. We work currently heavily with mechanical engineers, and a lot of the mechanical engineering codes have not necessarily used a lot of GPU. I know they support GPU, but we haven't seen the customer demand to use GPUs for compute. So although we have the capability, it's just a customer demand question at this point. Good question. Any other questions? Along the same lines, maybe I'll continue waiting for another question. InfiniBand is supported, so you can cluster multiple containers together. And Robin was here yesterday talking about Lawrence Livermore and their new system. The UberCloud containers have been run at Lawrence Livermore to see their scalability capabilities, and I would be happy to share results of that if you'd like to see it.